Hey there. In this video, we'll be looking at the factors on which the resistance of a conductor depends. The resistance of a conductor mainly depends on four factors. 1, 2, 3, 4. The first factor is the nature or the type of conductor. Nature or type of the conductor. Next is the length of the conductor. At third, we have the thickness, or we could also say the area of cross section. The area of cross section of the conductor. Finally, the fourth factor on which the resistance depends is the temperature. Now, let's look at each one of these and consider how these factors may influence the resistance. At one, we have the nature or the type of the conductor. We've already seen earlier that in nature, any substance can either be a conductor or an insulator. Of course, there are two more kinds, which is the semiconductor and superconductor, which you shouldn't be worrying at this stage. You'll be learning about this in higher classes. So, depending on the nature of the conductor, a good conductor has lot of free electrons. That is, the concentration of free electrons influences the resistance of the conductor. So, if you think about it, the more the number of these free electrons, it would be easier for the conductor to conduct electricity. So, in that way, if we take examples, substances such as silver, or you could say copper, or lead, or aluminium, etc., are very good conductors of electricity because they have a lot of free electrons. But on the other hand, if we take examples such as rubber, wood, glass, etc., these kind of materials do not have a large number of free electrons. That is, the concentration of free electrons in such substances is very less. Let me just write that down here. We have substances such as rubber, glass, wood, etc. Right? All of these are bad conductors of electricity, or rather insulators. Okay? So, depending on the nature of the conductor, the resistance would be less or more. The more the concentration of free electrons, the lesser the resistance. Okay? Now, coming to the second factor, length. Now, if you think about length, the longer the conductor, the more number of collisions a free electron would have. So, we already saw in the previous video that a conductor has positive ions occupying certain fixed positions in the bulk of that material. Now, if I have a longer conductor, electrons that are moving about would face more number of collisions. Longer the conductor, more would be the collisions. The collisions that these free electrons would have would increase rapidly. Therefore, the longer or more the length, more would be the resistance, right? The resistance would thereby increase. Coming to the next case, thickness or area of cross section. If you think about it, if we compare the thickness of a wire or a conductor, the larger the cross section, easier would be the flow of the electrons. That is, if we compare a thicker and a thin conductor, a thick conductor would offer less resistance. Hence, if the thickness would increase, or if the area of cross section would increase, the resistance would decrease. That is because now those free electrons have a larger amount of space or passage for it to go through. Next comes the temperature. If you think about temperature, what happens? If we increase the temperature of the conductor, we had free electrons and we had the fixed positive ions. The free electrons, with the increase of temperature, would start having more random motion. It would have more random motion. While those positive ions now, because of an increase in thermal energy, would start vibrating more. That is, the amplitude of these vibrations would be larger. Would be larger. So what do you think is going to happen? If there is more random motion and the vibrations of these positive ions would be larger, the number of collisions would increase. The number of collisions would significantly increase. That means by increasing the temperature of a conductor, the resistance also would increase, right? So this is how these factors influence the resistance of a conductor. This is a very qualitative approach. We'll be taking the same concept and trying to derive something known as the resistivity of a conductor, which we'll be looking at in the next few videos.